Welcome to today's Explainer. We're taking a fascinating journey right into the heart of one of the most talked about technologies out there today. We are going to completely demystify Ethereum. We'll look under the hood at its core engine, and even more importantly, we're going to break down the massive upgrades that are fundamentally changing how this technology scales and operates. I'm so excited to guide you through this. Okay, let's dive into this.
You've probably heard of Bitcoin, right? It pretty much completely dominates the headlines. But what about Ethereum? What exactly is it, and why does it matter so much in the digital landscape? Think about it like this. If Bitcoin is, say, a digital calculator, what makes Ethereum so profoundly different?
Well, Ethereum, which was launched by Vitalik Buterin back in 2015, isn't just an open-source blockchain. Its true magic, the real game changer here, is that it functions as an open platform. It allows people to build and deploy decentralized applications, or what we call dApps, directly on its network. So it's not just a currency, it's a completely open platform for developers to build on.
Because Ethereum is entirely permissionless, literally anyone can deploy a new application. Every single transaction gets validated across thousands of independent computers. So the crucial point is, this completely removes the need for any central authority or third-party gatekeeper. You, as a user, simply perform direct transactions via the network itself. No middleman required.
Now, to power all this activity without a central bank running things, you need fuel. Enter Ether, or ETH. It serves a really important dual purpose. First, it's how users pay for their transaction fees. And second, it's the exact mechanism used to reward the folks who are actively participating in securing the network. It's basically the engine oil for the whole system.
Let's look a little closer at that engine, specifically something called smart contracts.
A smart contract is essentially just a set of if-then instructions. Developers write these rules and deploy them to a specific address on the Ethereum network. And here's the kicker. Once deployed, the smart contract becomes immutable. That means it absolutely cannot be secretly changed later. It's entirely transparent, and most importantly, it's self-executing. The Ethereum network itself uses these exact rules to validate transactions automatically.
Let's look at this in practice to really drive it home. Imagine you want to pay for a decentralized taxi service. Step 1. You, the user, pay some ETH to the specific network address of the smart contract handling that taxi service. Step 2. Because you made a valid transaction, it triggers the smart contract's code, which is then validated across all those thousands of computers we just talked about. Finally, Step 3. Once verified, you get to access your taxi. You get the service directly, with absolute certainty, no third-party dispatcher sitting in a corporate office taking a massive cut. And this brilliantly illustrates how powerful the technology really is.
That taxi is just one example. But as you can imagine, smart contracts open up a massive world of capabilities for our daily lives. We're talking about operating entire financial exchange platforms, or getting paid directly for your digital posts on social media, or really facilitating transactions between any service provider and user. The possibilities are honestly endless.
But as with any huge innovation, this engine faced some serious growing pains. It created a major bottleneck. Let's talk about the need for speed.
Historically, the Ethereum network required immense computational power, which actually limited it to roughly 15 transactions per second. Yes, you heard that right, just 15. Compare that to traditional centralized networks. Visa, for instance, claims it can handle roughly 24,000 transactions per second. If Ethereum actually wants to be the base layer for a decentralized global internet, 15 transactions per second simply isn't going to cut it. It was a massive scaling problem that had to be fixed.
Let's move to and see how this builds into the big upgrade, energy and scaling.
99%. No, seriously, 99%. By fundamentally changing its consensus mechanism, which is really just a fancy way of saying how the network agrees on valid transactions, Ethereum implemented a monumental energy efficiency upgrade. They mapped out a way to reduce the network's energy consumption by over 99%. This completely eliminated the need for those massive, energy-draining computing arrays you used to hear so much about.
Now, what's really interesting about this slide is the sheer scale of the roadmap. The evolution here is staggering. We go from a launch of 15 transactions per second back in 2015 to that immediate 99% reduction in energy we just talked about. But the ultimate target for these future scaling upgrades, a whopping 100,000 transactions per second. From 15 all the way to 100,000. That kind of capacity flips the script entirely. It positions Ethereum to easily rival and maybe even surpass traditional centralized systems.
So what does this all mean? What is the ultimate endgame of these incredible energy efficiency and scaling upgrades?
Well, it's the hope of unlocking a truly decentralized future, a future where the engine of smart contracts can run fast enough and cheaply enough to literally be used for everything. It's all about empowering people across the globe to access services directly, instantly, and securely.
Which brings us to our final thought for this explainer. With Ethereum smart contracts providing the rules, and the new scaling upgrades providing the necessary speed and energy efficiency, the technology is fully falling into place to remove middlemen from almost every aspect of our digital lives. So I'll leave you with this question to chew on. Are you ready for a world without third parties? Thank you so much for joining me today to demystify these incredible tech. Keep learning, and I'll catch you in the next explainer.